Hello, this is Lee McWhorter, cybersecurity instructor for WazU. Welcome to the first special pre-recorded episode of the Programming Foundations class that's beginning this week. This episode is being pre-recorded because your instructor, as you know, is traveling to Vegas, have the CompTIAcons and DEF CON to attend, and really looking forward to it. So as we've already discussed, my availability will be a little different, not too bad except for Tuesday, as I told everybody. But we'll do things a little differently. I'm pre-recording these workshops, so everything will be ready and available for everybody to get rolling into the new mod as we start on Monday. And then, of course, got everything set up in the learning management system. In some cases, as we discussed, we'll have to reschedule or miss a few one-on-ones, but I'll do some office hours to kind of make up for that. In other cases, I will make some, especially some of the later folks where I have time later, set later in the evenings, later in the week. But anyway, that's the story, and that's actually kind of redundant since I just had a one-on-one with you a couple days ago and we went over all this. But congrats to making it into the last tier of the program. You have this class, then the combo web app / project management class, and then the final threats and vulnerability before you go into the final project to get out of the program. But this is Introduction to Programming Foundations, and we are using Python as our language of choice. Python was chosen for a number of reasons for our program. We could have picked pretty much any language, especially from our full stack sister programs library of courses. But Python was chosen because Python is just really a super popular language right now, used in behind a lot of the tools. If you remember, we've had exposure to at least very high level Python before, and that's because we play with SQLmap already. SQLmap is a Python program. It's written Python. It's SQLmap.py. So it's a Python script, basically, or program. And so, obviously, and there's others like that in our field, many security tools and scripts that are written in Python. As a matter of fact, a lot of folks in different aspects, especially in the pen testing side community, sort of have many times a library of scripts because they may be gaining access to a device through some kind of vulnerability or exploit, get themselves a shell, but there's a very limited environment. It could be even a device like an IoT device, and not necessarily the ability to load up the entire XYZ framework or even get Nmap or something. But they find there's Python there, and so now a little bit of Python scripting, cut and paste into their terminal, and now they can run some code, and they may have built a little network scanner, a little version of effectively like a Netcat, to connect in various tools like that are kind of in their library. It's kind of cool. I have a few sort of saved, myself, where people have shared some ideas and some cool widgets like that. So very important language. It's also hugely powerful in a lot of other niche markets. Our sister program, Data Science, uses it extensively as one of their main languages to do a lot of the data analysis. And even within our field, higher than our program, going on beyond, say, like to Pentest Plus, as you know, one of my favorites. That's one of the 4 languages that is required. Bash and PowerShell, Ruby and Python, at least a scripting level, a basic programming knowledge level in all 4 of those languages. And of course, in our program, we've already covered Bash, PowerShell, and now Python. So I really like Python because Python is a really cool language. It's a little different in some of the things they've chosen to do in their syntax, and I'll talk a little bit about that a little later here in a minute. But I really like Python because it has a number of things going for it, in my opinion. One, it's a great language to, as this course does actually, start somebody with sort of the basics of what we call the procedural programming paradigm, where we're just scripting, sort of building on from what we learned back in system administration, the shell scripting exercises. So, because all those basic things we learned there, variables, and that there's flow control and loops and ifs and all that's, yeah, Python has all that. So if you remember that, where you're already a step ahead jumping into Python, it's all about just how does Python do its if statement, how does Python do its loops, how does it define variables, and etc. So there are always differences from one language to the next, but Python is a great language to take somebody from that beginning procedural paradigm, kind of linear scripting kind of programming, with some flow control and loops, of course, thrown in there, and then take you all the way to, as we'll get to in the second and third weeks, the object-oriented programming paradigm, because ultimately Python actually is an object-oriented language. Though our focus won't be as heavy on that, we do want to expose you to it, and you will, by sheer definition of working with Python, run into it, even if you don't probably realize that that's what's going on in the beginning. So this course will take you through a little bit of all that. So we'll start with some basics of programming. We'll move into some of the kind of more intermediate features and data structures. We will then move into object-oriented programming, and even talk a little bit about testing and debugging and things, which are important to know. Not so much from, I mean, if we're going to write code, we're going to customize some kind of script, then yeah, it's good to know. It's also good to know because that's what developers do. And even if we don't go on to do a lot of developing, some scripting, whatever we may do, we may have to work with the dev team. We may work as part of a DevOps team, and we want to understand that that's especially when we want to be able to work with those developers to say, as part of your testing, can you do this? And then, of course, as it, say, moves to the testing dev server, then maybe that's when we're stepping in and doing some of our testing, to check the app and the website or whatever and make sure it's good. So that's the goal of this course, actually, is not to master, and you may very well. I've had a number of students to just kind of fall in love with this language. Kind of the shell scripting kind of got them thinking about it. Maybe they already have some background, but then they kind of just roll with this. And you ultimately keep in mind that this is another class, one like Network Foundations earlier on, where there is a heavy weight on the last final project, because it is a kind of, okay, you've learned all this, can you put it together in this simple little task list application? So anyway, that's the quick overview. So let's just dive into lesson one. The main parts of lesson one, and I'm going to share a screen and just take you through a few things, but the main part of lesson one is all about basically getting set up. Not uncommon in many of our courses, right? The first chapter has got some intro information, and this does too, because it begins to talk about some of that same stuff that we've already talked about vis-a-vis the scripting, the shell scripting that we discussed before. So it starts talking about things like variables and strings and, the basics of, simple elements within comments, things like that, all the basic things, that we talked about in that scripting lesson as how they apply to Python. But of course, one of the big parts is the installation, right? And so you're going to find that you're going to have to visit a couple places. You want to download a couple different pieces of software, and I'm not probably doing exactly like the lesson, but just want to show you. You're going to come over to Python, and then right now, the most current version, and we're still in the 3 family, so I know the course was updated a little bit back, and it may say, I can't remember what the picture shows, but it's still the 3. We're still in Python 3, so this is a slightly newer version, of course, nobody should be using Windows XP anymore, so we don't care if that's not supported by 3.5 and above. But so you're going to download, the software, pretty easy, set up, save the file. I already have it. I may not have this version, but I'm not going to worry about it right now. And so you'll download that into your download directory, and then of course we could install Python to actually get it onto our system. The other thing that you're going to want to do, and the lesson calls for, is to grab yourself a copy of Visual Studio Code, or VS Code. Visual Studio Code is kind of the default editor that we use across the Wazoo programs. We use it ourselves, so like when I design the courses, I'm actually writing all the Markdown and other things and embedded HTML and whatever inside of VS Code, and then of course using Git and checking that in and being as part of their dev team when I'm on the curriculum side, or the curriculum team. And so I like this editor a lot. As you can see, one of the things that's really cool about any kind of really solid editor, and there are others out there, the one advantage of using VS Code here at Wazoo is that all of our lessons will match if you play along. But you'll see there's lots of extensions, including Python right there, that you can add in. And when you do, then when you're writing code in that language, you'll see that over here, like this sample code, it has things like color coding to make sure your different elements, from variables to functions to loops and things, are all the same. If you see everything go all red or something weird, then that's a problem. What did I do? I left out a bracket, or I didn't close a quote. I didn't quite type that syntax right. But then you can see it even has the ability to help you complete things, drop down so it can pick other objects within your code depending on the languages you're using. And it's, much better. Technically, you, just like with the shell scripting, you could write a script. You can write Python in Notepad, and just, as long as it's a text file and saved with a .py extension and everything else is set up right, you can run that script. But one of the things that's really nice is that VS Code not only integrates the ability to help you write, syntax check and all that of all these multiple different languages, but it also integrates the command prompt or the console right there into your environment so that you can run the scripts all within one integrated environment. It's really embedding and running PowerShell in the background, running the effectively a command prompt so that these scripts can be executed and we can see the results. And we'll show you a little bit of all this. Once again, you're going to download the program. There is, as you can see, versions for all the operating systems. It's one of the things that I'll have to give Microsoft, I continue to give them props for, is that they continue to, after a long time to get there, they've really, especially through Azure, and a lot of their doing as they move forward, that they are becoming a big embracer of more of an open source model. Technically, this is an open source product in a way now, as you see, built on open source. And they actually have available packages for both Linux, different, the different sort of distributions. The deb would be for Ubuntu, the Red Hat packet manager would be for like Fedora and stuff like that, the other flavors, and of course Mac as well. So you'll be installing both of those. And then when you get them set up, then you can do a couple different things. And there's parts of the lesson one cover some of this. But like if I bring up, that's not what I wanted to bring up first. Actually, I wanted to bring up the command prompt first. So we'll come back to that in a second. That was VS Code, a little tease. So in this case, I've just brought up a PowerShell prompt. But one of the things I wanted to show you, because they take you through it in the lesson, is that, and I'm going to try it both ways because I never remember. It kind of varies depending on how you set it up. And so, okay, you'll see that I'm actually just a couple notches back, the 3.7, and I haven't, so I don't got the 3.74 at the moment. I'll fix that later. Not really worried about it right now. But you can see once I typed Python, or in some cases, depending on the OS in question, more times than not, it seems like when you try to do this on, say, like Kali or Ubuntu or something, you need to type Python 3. But it kind of depends on the path and how things are set up. You'll see that we're now at this strange little prompt, and it says Python 3. And that's because we are actually, we're at the Python interpreter. We can interact with this and even do some simple little bitty programming, assuming I don't mess things up. So let's do something like, just for giggles, we understand from our shell scripting lesson. And if the first lesson in this has any issues, you might kind of go back and look back at that if you need to see if you're having any still concepts with just difficulties with things like variables or whatever. Then you might go back and see if one might jog the memory better as another example. But in our case, let's just say I'm gonna call this vname. I'm just creating a variable here, vname, and I'm going to set it equal to Lee. And of course, I've issued this line, nothing seems to happen, right? And so what I've done though is I've allocated a variable, I've assigned a variable called vname, and I've given it a string, put in quotes, a string value of my name, capital L-E-E. If I basically print that back out, then that's a print command. I used a function. It's actually within the Python model, to be honest, not to confuse you yet, because we'll talk that later, but it's really, any string is an object in Python, so that's actually a method or function of that called print. And so I basically tell print to print the vname variable, and it comes back with Lee. I could do things like print a string, and it'll print that. And we can play with this, and right now I could still come back again and print vname again, variable name, and Lee's still there, because once again, a variable is defined and stays there in memory until the program is done and clears, or until you change that value yourself. And so here's this nice, and this is a great way to see that you got at least Python install working right, Python's doing its thing, and then you can play. And actually, you'll see people sometimes use this. Maybe they've written a very elaborate Python program, and then somewhere in here, there's a problem. You know, the code's not working, it's either throwing errors or maybe it's not. That's the worst. It's not. It's syntaxually correct. It's correct syntax. Syntactually? I like that word. I don't know. I make up words all the time. But anyway, it's, you know, correct from syntax, not throwing any errors in the editor. But when you run the program, you're not getting the results you expected. So many times, instead of having, you know, that we might take little bits of code and just try to replicate, you know, let's see, does that line, what happens if I do this and this? So you can see we can play with little blocks of code, but this is not really how you're going to use Python most of the time. If you wanted to do something, you know, pretty simple, you know, kind of funny, but we could do something like a little math right there at the command prompt, and you could write a more elaborate, you know, with the standard slashes and asterisks for and parentheses, and you know, we're kind of getting a little bit into the next lesson. But when it comes to the, if you remember PEMDAS, right, you know, parentheses, exponential, you know, that order of operations, right, that would happen. Math rules apply in programming and math. So we have a little calculator here, but you know, once again, you're not really going to use this. This is more of a testing, debugging environment, and in our case, to make sure things work. Now, if you can't type Python or Python 3 at the prompt and get to this because you're getting an error, command not found, let me show you how to fix that, because it's supposed to be done when you do the installer and setup all right, but it doesn't always work, and so for various reasons. And so one last thing just at the moment for here is that because Python is we're in this Python mode, we have to type quit parentheses open and close because we're calling the quit function. And that gets us out of the Python interpreter, and we're back at our PowerShell command prompt. And we've now lost that variable because it went away, you know, stuff like that. We've closed it out. But if you're having, especially on, and there's a variant on this, I can't demo it right here, but if you're having trouble getting Python to run after the install, one is you might just try a reboot, even though it doesn't necessarily require it. Sometimes that's useful. The other thing is that you may have an issue of your environment variables aren't being set up right. So if you start typing environment variable, you'll see edit the system environment variable show up on your, you know, best match. And then down here on this system properties dialog, which you can also find a number of other ways, including through the control panel, you'll find the environment variables button. And then you'll see that there's a number of different things in here. The main thing that matters, and the only thing that matters to us in this context is, and you can even see here, Python, you have the issue of you should have Python on your path if you want to be able to just basically tell it to run a .py script. You want VS Code to run well. You want to be able to just type Python and it start the Python editor. You want to type Python space some script name and have it run without having to fill in the whole path. So we want this on the path so it'll work with just typing Python. So you would come into your environment variables and to search for it, system properties, environment variables, select on the path, click edit, and you'll see we have these different lines. And in this case for Python, and you'll see even VS Code. So if you have the same problem, if VS Code doesn't seem to run like you want it to, or if you ever are, you know, wanting to follow maybe one of the instructions says to just at the command prompt type, you know, type VS Code to launch it, and that doesn't work. You can obviously run it from the menu, but sometimes the instructions are having you be in a particular folder and, you know, start a project right there at the command prompt. And if that is the case, then once again, maybe it's a path issue. And so you see VS Code's kind of easy. VS Code actually lives in like where you would expect, program files, Windows, Microsoft VS Code, and that bin folder is where the binary is. In the case of Python, Python lives in a weird place actually. It's kind of buried under your own home folder, whatever your name. So home username, Lee for me, and then a hidden folder actually called app data, which is a folder that if you're in cybersecurity, you need to know about anyway, to be honest, because it is a folder where a lot of stuff that's your own personal stuff, in this case Python, the whole program is buried under there. But there's another temp folder under there, app data local temp, and that's a lot of times when you get something like maybe malware or you know, like a search redirector, some kind of weird little adware or something like that, it may hide down in that app data local tree. This is stuff that is only for you. So the way Python is installed here, it's been installed under my user. And so it's under this app data local program Python, and then there's the Python scripts and the Python folder where the Python exe would be. You can find that, of course, if we, we can look at it this way. So we can go out to C, we can go to users, we can go to Lee, and then must not be sorting right here. Oh, I don't have it hidden. So you may not see it. Say I'm not showing hidden files. So where's app data? Well, if all fails, you can type it in. See, I've already done this before. And so you can type it in at the prompt and see, here's these 3 folders under here hidden under app data and a lot of stuff. See all the stuff that you're like Adobe and other stuff that's been loaded behind the scenes. This is where it goes. And so if we come in here to programs and then Python, see, I've got actually an older version on here as well. So I've switched to the newest, the 3.7 at least. And so then there's, like I said, the scripts folder, and then Python is sitting right here waiting for us, right? So we got to make sure that path, wherever, ideally, to be honest, most of the time it does work. It's not actually an issue. This will be added by the installer when you run the install. But if you are having issues with running Python at the command prompt, and this would apply to Mac or Linux as well if you're different mechanism, but still you got to set the path. It's got to be part of your path environment variable, so you can do those things. Now, so lesson 1 is all about the setup, and then it begins to talk about a lot of basic stuff. It even covers some if and else. Like I said, if you kind of look at, as you're working through 1 and 2, which are the setup and just sort of the basics of the Python syntax, the basics of the Python structure, and the language and how it works, then one of the things you're going to want to do is, like I said, I think it'll be pretty straightforward, but if you are having any issues for comparative purposes, go back to that system admin lesson 5, the shell scripting lesson, read that again to kind of get the simpler languages back in context if you're having any issues. And so as we move through 2, we cover all the things like all the operators, plus, minus, divide, parentheses, all the different types of, if we're trying to define a variable, like in that case up there with the v name equals Lee, then we use 1 equal sign. If we're trying to check if something's equal to something, we use 2 equal signs. And we have all kinds of other operators, including logical operators like and or the greater than and equal tos, so all of those that are covered, even things like Boolean, they do cover the PEMDAS again, parentheses, exponential, multiplication, division, addition, subtraction, right? That's the order of operations. So more complex stuff gets done first, or things in parentheses first, then the more complex stuff is, sort of the higher order stuff. And talk more about strings again, including the fact, as I already said, the print is a method. There's a lot of basically functions that are built in, so you can manipulate strings. And so even though we're not really introducing the concepts of object orientation, you see these things in the lesson like something, dot lower, dot upper, and basic, I'll show you an example in a minute, but they're basically, they're their methods or functions that, and if you're, we'll talk about this when we hit the object-oriented part next week, but in programming, we usually refer to like the print as a function, something that is basically somewhere there's a few lines of code. Somebody else usually wrote it, right? It's already off, or maybe you did yourself and just defined it. But when you can call that function and do it without having to repeat those lines of codes over and over again. When we do it in procedural programming, we call it a function. When we do it in object-oriented programming, it's called a method. And to be honest, that's 601, half dozen, they are the same thing. They're just some code that's been packaged together to do. So somebody wrote code for us to just be able to type print, and it takes whatever we give it and prints it out on the screen. And then we may, in our future programs, write our own function, like calculate bonus or something. And that way it has all the code and the, variables and the loops and the math to do that calculation. And then we just have to call calc bonus when we want to call it. So if we're doing it in more scripting, procedural languages, we call them functions. If it's part of object orientation, we call them methods. But really, they're something we can use. They're a feature we can use effectively. So there's a number of the string methods, as they're called, upper and lower and replace and things like that. So you'll go through all that. I think 1 and 2 you'll find pretty straightforward. And I'm going to come back here when I switch just in a moment. I'll show you some examples of some of these things as well. In addition to this code, I've got a few little hodgepodge of examples in my VS Code here in a minute. And so that moves us kind of into three. And three is called list and loops. And basically, assuming that based on the shell scripting lesson and now in this first lesson or two of Python, okay, you've understood how to do some basic kind of scripts and a little bit of functionality here, from printing things to doing math, doing whatever. And so now, beyond just having variables, single use variables like vname equals lee, we want to, many times in a program, we need to store a whole bunch of variables. We need a whole bunch of data points for analysis purposes. You could say, like, if I wanted to, in my program, calculate your average, I would need to have all your grades, right? They would each need to be stored. Now, I could create a variable called grade 1 and grade 2 and grade 3 and grade 4, right? And have a bunch of separate variables. But I can also, in all programming languages, create a group of variables under one name. And in Python, we call that a list. In every other language just about in the world, we call it an array, A-R-R-A-Y, an array of data. Either way, it's basically, instead of just having like vname equals lee, that's a variable. Vname is the variable, and it's set equal to lee. But if I create a list in Python, I can give it a name, and then I give it a number of data points. So let me do this. Let me switch over to VS Code here and give you an example of that. Here is a perfect example of a list in question. So this is just the list name. It's a variable still, but it's a list in this case. Matter of fact, you can see it's even saying planes, it's a list. So this is VS Code. See, I've got a program called main py, so my main script, my main function, at least for this example. This is a lesson 1 kind of example. I don't know why I call it lesson 1, because list is really lesson 3, but some of the other stuff, print and things, are really earlier examples. But you can see I've defined this list and I've given it the name planes. And then instead of just saying it's equal to 1, I've set it equal to a comma-separated list of values, all strings, right? So jet, biplane, glider, and test. So now these examples then use either just print the whole thing. So you can see I print planes. And then in this case, I'm going to loop through it. For each plane in planes, I'm going to print the plane. So it basically should print them each out. And then there's a way that I can reference each of these individual values. And funny enough, it's just, once again, an example. It's really easy, actually, once you get used to the fact that computers are weird and almost always start counting from 0. So if you think about it, like in the VYOS router in GNS3 or any of the GNS3 topologies, even the virtual machines for that, standalone for that part, the first adapter, the first, basically network interface that's in your machine, that first network card is always ETHO, right? ETHO 0, and then ETHO 1, ETHO 2, ETHO 3. So in a list, if we want to get not the whole list, but individual values of the list, then we're gonna reference them by number. And so the first piece of the list, jet here, which is a string, as you can see, it pops up. It's the cool part about using VS Code or any nice editor is it helps define things for you, and color codes everything. If you got something spelled wrong or messed up, if I intentionally break something, then if I try to run it, in this case, it's not throwing a fit about that, funny enough, but in some cases, if I break certain things, obviously, let's see what happens if I mess that up. See, that changes the color, so I'm not getting a function there, which is yellow. Oh, okay, I mistyped it. So, but we want to reference one of the values, then 0 would be the first one, and 1 and 2 and 3 would be the values. So down here, I'm going to print individual values, but not using a loop. I'm just going to call the ones I want. And then we have the ability to just print one value, or I can change the value. See, it used to be jet, and now I'm going to change it to jets and then print it back out. And then I don't want to talk about dictionary. That's actually starting to get into next week. But let's run this. Now, this is one of the things cool is once you write a piece of code, and you do need to, it's one of the things about, like, just show you, like if I want to make a new file, so I make a new file. I got a brand new file here, untitled something. Okay. But if I start typing something in here for a new file, like print, hey, it's not color coding. What's going on? Well, what's happening is right now, this is a blank file, and VS Code has no way to know what the heck you're doing. So what you have to do effectively is you need to save this file if you don't already pre-create it. So I'll just save it in here in my continued lesson 1. But what you're going to want to do, we'll call it untitled2.py, since I already have one. But you need to give it a .py extension. As soon as you do that, see how that changed to yellow? Now it knows, oh, Python. Okay, cool. I got that. I can check it and do whatever you want. Now, if, of course, one of the things that the lesson takes you through, but over here on extensions, you can find, like, there's the Python one. I've already got that one loaded. So that's, you're going to load one of these so that it can do that checking for you. So anyway, if things don't seem to be working, you've written all this code, hey, it's not running, well, save it and give it, lesson1.py, lesson2.py, etc. So let's go back to this main. So we've defined this list, which is just a variable with multiple values, and we're going to play with it a little bit. So let's run it. Now, this is the cool part. Once you have something written in VS Code, you can just right-click and go down here and choose Run Python File in Terminal. Oh, I did the wrong thing. What did I just choose? Run selected line. Okay, well, that would have been cool, except I had a blank line. That's not what I wanted. A little too far down. Run Python file in terminal. And now look, let's see how this worked. So if we come up here, all right, cool. So we ran the block, and so then it says it prints the list, right there, prints list. That's that line. That /n is talked about in lesson 1. That's a new line character, so we have our blank line in our output. And then we said print planes. Well, printing planes is the whole array, the whole list, as Python calls it, and looky there. There they all are. Cool. All right, so then we come down here, print loop and a blank line. Perfect. And then it says, for each plane, see the singular, in planes, and then we're going to tab in and we're going to print plane. So it's going to loop for each one. And you can see right here that that's exactly what it did. Jet, biplane, glider, boom. Then it printed individual values. I really should put a /n in front of these so there's another blank to really separate these out now that I see that. I'll show you that in a second. We'll fix it real fast. So, and then in this case, down here for individual values, you'll see that we only print jet, biplane, and glider, 0, 1, and 2. Cool. And then other stuff, we're going to change the value of plane. So in other words, if you want to change part of that list, you still use that number notation, the square bracket number reference to reference that value. And this is just basically like referencing one variable in there. We're saying, I want to change the first entry in that plane's list to jets instead of jet. So then, of course, when we print back out that 0 after we've changed it, then right here we get jets. And then the dictionary one, like I said, it's similar variant, but I'm not going to show you. So, but let's clean this up a little bit. How did that? That seemed a little weird. So, okay, cool. We want to clean this up. So I'm going to come back in here and throw myself an extra new line in each of these. That's a little harder to read. And then that way, it'll make it a little easier to read. I'll have spaces in and around. And then probably what I want to do is get a little nicer. Save this for future, right? Oops, don't want to select it all. Darn it. And so I'm just making changes, and I'm making all caps here. And I'll worry about the dictionary later. I think actually to push that off the screen, we'll do a couple of them so it separates it off. So now I've changed these things. And now just for fun, what I'm going to do is I'm going to mix it up. I'm going to come in here and change this to 3. I'm going to print that last value we didn't print last time at the first of that order because it doesn't matter. I'm in control. So if I save this, you can see it was marking it needed to be saved. Then if I rerun this little code here in the browser, you'll see that things are a little cleaner now. Oops, that was it. So it starts to run. Now we have some extra spacing. So this prints the whole list. This is the loop through all of them. Here's the individual values, but you'll notice we got this test value now because I changed that from a 0 to a 3. You can see adding those extra spaces in, spaced it up nice. I capitalized. So this is the beauty. It's actually one of the things I love about programming in general. In some of the higher order, more elaborate, application development, you may have to wait a while to get your gratification. You write some code, you fix things, and then you have to compile it down to an executable program. And that may take a while. If it's a big program, maybe part of, you have to get work from other, you have to bring it all together. Dev team's got to compile the whole thing for you to test it, and you have to go into testing. An individual programmer writing on web pages, writing Python, Ruby, Bash, PowerShell script, things like that. The beauty is that you can get instant gratification because you write and you save and you run it again. If you're writing web pages, you write the code, you save it, you reload your browser, and you get that either works or everything fails miserably, but you're getting that instant feedback. And, just like I've tried to emphasize to all you folks throughout, especially when you hit occasional trouble with the networking or an attack sequence that's not quite working, if you run into problems with any of this, take a step back. Don't start completely over. Just take a step back. What was working? Check each thing. You can do this line at a time, right? Save and run, and see how everything's working. If it's not, fix that until you move on. And then just take your time. And of course, let me know if you have any questions trying to understand any of the concepts. So we talk about a few other things in lesson 3 as well. Truples are basically what are considered to be immutable lists. Or in other words, you could say that if a variable is a variable, but then a constant is something that doesn't change. Well, a list is a group of variables that can change, and a tuple is a group of constants that can't change. But it's pretty much the same that you reference it, and the numbering kind of works the same. It's all about how they're defined when you create them. You'll notice that unlike when we did a variable, we just said vname equals Lee. Here we're using the square brackets to bracket the entire list, comma separated. If the string, quotes if they're strings. If it was numbers, we could just have them back using. We just put numbers in there. We didn't have to, if we wanted to be strings, we put quotes around them. And so then there's some additional, ability, some functions that we can work with to play with the individual values. And then of course it wraps up with like the for loops and things like that. So really these first, while going more detail and going very detailed into Python, in a way, these first couple lessons are a high level, or a little deeper into what we covered in that shell scripting, the basics of programming, the basics of what the language does, flow control, ifs and else and loops and things, defining variables, defining list in the case of in Python, learning how to do the basic functions. And that's where you are at the end of the first week. As we go into next week, we will talk about another form of grouped variables that Python calls dictionaries, or the rest of the world calls an associative array. But nonetheless, we'll go into that, talk about dictionaries and some other functions, and get into functions in lesson 5. And then we will finish up that procedural first half of the course and shift gears and begin to introduce you to a little bit of the object-oriented, and then save the last of that and the debugging and final project for the last week. So, all right, cool. That is the Programming Foundations first workshop. Let me stop my screen share. This will be waiting for you. You'll find it when you get into your class on Monday. If you have any questions, especially as I tell everybody, and one of my emphasis for this week, where I'm going to be a little less available given my travels and activities, is that I want to really focus on you folks that are in like the networks, this class, because this is an install. It usually doesn't have much of a problem. The biggest problem is that pathing. Like if things don't seem to work, you can't get things to run, particularly at the command prompt, or you're not able to run it through the terminal, things like that. We need to check the pathing and the configuration of VS Code to make sure they're both, they're set up and you've got that extension loaded for Python. But most of the time in this class, actually follow the instructions, you install the pieces, you'll have it all working, and you shouldn't have any problem. But if you do, let me know, because that'll be one of the things I definitely want to get you up and running, so that you don't get in any way, shape, or form behind, and you shouldn't. It's a fun language, and if you have any questions, let me know. We'll talk to you later. Thanks.